Hello everyone. Thanks for being here. Some dedicated set of people, huh? Pretty late in the evening, but thanks for being here. Appreciate your time. Today, I'm going to talk about Verizon's journey towards cloud transformation. I know it's been a long day, but hopefully I'll make this session useful for you. My name is Syam Suri. I've been with Verizon for the past 14 years. Right now, I'm primarily focused on digital transformation of sales and support experiences for Verizon Fios business. Today, I'm going to talk about our journey in that process. Everybody knows Verizon. Anybody who doesn't know Verizon? Yeah, so in terms of size and scale, everybody knows, but I'm going to touch on a couple of items that we basically are very passionate about in Verizon. Over all these years, if there is anything that is constant, it has been the change. So change is the only constant. From business perspective, Verizon underwent change from a telephone company to an internet service provider to now we are leading the future into 5G technologies. So we say in Verizon the change energizes us. That is something we have been bringing forward into our digital transformation journey as well. Another motto we have at Verizon is we don't wait for the future, we build it. So what we mean by that is instead of waiting for someone else to define our future, we embark on the journey ourselves first so that we can be in the forefront of the change. So you will see throughout this presentation these two underlying themes on how we are defining the strategy to move forward with the transformation. I know these lines feel like cheesy ad lines, but basically for a company like Verizon with its size and scale, essentially this forms kind of the credo statements for the entire community to move forward and embark on the journey. So throughout in the presentation, I'm going to talk about how we defined our strategy and kind of got the alignment and moved forward with the technology space. So in terms of agenda, first we will define what our challenges were and how we set our goals and principles for the transformation. And I will touch upon what is the solution architecture we set up, and I'll double click on each one of the layers to talk about the details of how we went through the journey. And then finally, we'll talk about the takeaways and also the results we achieved out of the first MVP that just got launched. So in terms of the problem statement, from business standpoint, Verizon has been undergoing a lot of change. In the past, we used to have silos in our business like Verizon Wireless, Verizon Fios, Verizon Business, separate entities. We are trying to break those silos and offer products that go across the Verizon Business entities, and so that we can offer value to the customers. So and other things we are also trying to address are provide innovation to the customers in terms of value on top of the core network instead of just being the dumb pipe that exists on top of which other vendors provide the services. So in addition to that, going to market has been a biggest challenge for a company of Verizon size. So we are always trying to look for changes where we can reduce the time to market. And we want to become more like a technology company as opposed to a telephone company where anything you want to deal with, you need to call. Instead, we want our customers to engage with us on a digital platforms. In terms of Technology challenges. Obviously, when we have business want to move with agility, we have to have our technology transformed as well. All the drawbacks you see are the regular ones you see with monolithic individual entities. The whole stuff about having inflexibility in the platforms because it's monolith, and operational bottlenecks, and in the intrinsic inflexibility and instability that the monolithic platforms offer with custom code. So in general, we also, because we have such a proliferation of technologies, we ended up over a period of time ended up with an alphabet soup of technologies. So that also has been a big challenge for us in terms of moving fast and providing flexible services for our business. So and the other thing that goes with it is the culture we have. Where mostly it was a waterfall kind of a model where there are too many handoffs, and that causes intrinsic delays and higher costs to market. So obviously, all the challenges become the goals when you want to transform. So the goals are how you can come up with a solution that provides a better time to market and at a reduced cost, and at the same time also use modern ways of development culture, so that we can remove the silos and handoffs and improve the collaborative environment. And more importantly, over the past few years, there has been advances in technologies where customers are not just dealing with us in web and mobile space. Now we have AI-based chatbots and Google Home and Alexa kind of devices. So we would like to interact with the customers in those spaces as well. So there is a need for support, technology that supports multiple devices. So the technology needs to be flexible enough. So we set certain design principles. Going cloud native obviously is the obvious choice, primarily because that is one of the bottlenecks we saw, where in setting up the infrastructure itself, 30% of my capacity has been constantly engaged in constant refresh of the hardware and software and so on and so forth. So we wanted to cut that down. And obviously, there is operational overhead also, where we have engineering team, we have infrastructure team, we have system admin team, and all that. So going to cloud native is an obvious choice, where all these things come as services that can be automated. And in addition to going cloud native and microservices oriented, API first approach is another thing we wanted to embark on. Like I said, if we have to go and support multiple devices and different types of technologies, we cannot simply have a direct client server kind of an architecture. We need to go API first. That way, depending on the experience that you want to define, you can essentially start with the APIs first and then go forward with parallel development for various things. Secure by design is something we want to emphasize, where instead of coding for each and individual services in a custom way, our goal was to centralize that into a place where we use standard methods instead of each and every developer worrying about how to make their code secure. One of the major bottlenecks we see in the existing infrastructure, existing setup, is the handoffs, where we have a development team, a testing team, a CM team, a production support team, and so on and so forth. So in order to manage all these, the handoffs between all these things, there is now additional overhead of documentation and detail, conference calls to kind of provide the handoffs, and all these things obviously are bottlenecks for us to really go fast to the market. So we wanted to address that. So considering all these factors, we went about the evaluation of various technologies and products, and came up with a tech stack that we would like to adopt for the entire organization. Now, before we go into the technology, we also needed a big change in terms of our mindset in our development culture. So we looked at we have been practicing agile-based programming for quite some time, but as you know, with the kind of mindset of waterfall, what happened is even within the agile mindset, people found innovative ways of a waterfall methodology, where the people insist for user stories from the business, and only then they will again schedule handoff discussions and so on and so forth. So agile mostly felt like waterfall still. So we went back to drawing board and kind of looked at all other methodologies in the market, like XP was one of them we looked at, and several others. But for our kind of a setup where we have an onshore development team and a huge development shop in India, we needed a model where we can kind of ensure accountability and collaboration among the set of people involved, and also both business and the engineering needs to feel the accountability and ownership of the product that they are building. So we came up with a concept called outcome-based product team. It is not a new concept, but this is something we have established as a model we will follow. So where the product manager, product designer, and product engineer, they form a collaborative team responsible for the product they want to build. Instead of taking up projects, they will take products, and they will constantly work towards building functionality and as a product, as opposed to impacts on a particular project and application that they need to involve. So they make decisions among themselves on what should be the best thing for the customer, and what is the right experience, and whether it is feasible to do that way or not from engineering standpoint, and whether it is viable from the product standpoint. All the decisions are being made together, and they go forward with iterative implementation. So this avoided a lot of handoffs that needed to be done, and as a result, it eliminated a lot of waste and improved the overall flow of development cycles. Now, with the development culture in place, we went ahead and defined the architecture we wanted to go with. So to support the multiple different clients, obviously we needed a sound platform, API platform. So we selected Apigee as our gateway to where we host all our APIs. And Spring Boot and Spring Cloud on PCF becomes our core of the platform for hosting the microservices. Redis is the clustered cache, and we moved away from the Microsoft SQL Server and Oracle databases we have into a Cassandra-based data store, NoSQL data store. All this is deployed on Amazon Cloud. So in the rest of the slides, I'm going to double click on each one of these layers, and I'll talk about what are the details we did there. So first thing is the Apigee API platform. So for us to support multiple different user experiences or devices, we needed a platform where we can quickly define the APIs and manage them well, and it needed to be scaled. It needed to provide the scalability and security as a central place. So in the past, we used to kind of manage all this with custom coding. So this is where we said, instead of discovering all those things, it is better to go with a standard product that provides all the scalability, security, and other standard features as out of the box, instead of us inventing the wheel altogether. So Apigee became our gateway across the enterprise, not just for the applications we are building within Verizon Fios, but across Verizon Enterprise, Apigee is being used as the API gateway. So that way, in future, when it becomes API-based economy, we would be able to seamlessly expose the APIs we build to the external world for third-party integration and so on and so forth. Now, having the platform alone is not enough. We needed to also change our way we approached the API development itself. So that's where we said we will go with API first based approach. The main advantage we see with this is that instead of waiting for the entire service to be built for the others to come and integrate, we go ahead and define the APIs in the Apigee platform, and they become the basic definitions with interface definitions with stubs already attached. That way, there can be parallel development. The front-end engineers can go ahead and consume those APIs and build all their experience, and go forward with fine-tuning their experience part of it. And then while that is happening, in parallel, the backend engineers can work on adding the business logic to those services. So this has worked out very well for us in terms of taking two parallel threads at the same time and make progress overall. And also, we just don't have to work on one single experience on one particular device. We could go ahead and do it for other devices also, while the other teams are working on their respective aspects of it. For example, we could go with native app development functionality along with the web development at the same time by consuming the APIs, and they could go ahead and completely test end-to-end and fine-tune their experience completely using the stubs alone. After that, when the backend services are plugged in, seamlessly the testing could happen. So that has helped us. Along with that, one other key thing we have implemented is, while APIs are defined, it is just not enough to say that, okay, we defined the APIs, people can go ahead and use them. We needed a proper documentation. This is where we made sure we have the right solutions in place to auto-generate the documentation. So the way we implemented this is, we used the Swagger, of course, supports OpenAPI 3.0 spec. So the developers, as they are defining the APIs as stubs, they input the necessary tags into the code, and then we have written scripts to generate the documentation automatically and deploy them onto a documentation server. And those scripts also will look for any missing tags or anything in the documentation and automatically generate Jira tickets. That way, the developers, no developer wants to spend time on writing Word documents for documentation of APIs. So we basically used this process to automate all the APIs documentation in a way that it becomes natural, and developers all have to focus. They have to focus on implementing the business logic, and any discrepancies or omissions are identified and Jira tickets are created, which can be addressed. So that way, any omissions are addressed automatically. The generation of documentation, maintenance of it is also handled automatically. Going forward, if you go to the next layer, that is the core application layer, we basically used a pattern called a microservices layered architecture pattern. So if you look at transforming from a monolith to a microservices based architecture, you tend to basically go ahead and slice the monolith vertically into smaller chunks of in terms of functionality. Now, when you're doing that, you also have what this pattern does is it also advises you to slice them horizontally as well as needed. Obviously, there is flexibility where if you don't need to, for a particular function, let's say a credit check, which is a singular function, you don't need to implement all these layers. But in cases where, for example, address lookup, if you are qualified for FiOS for your address or not, it is just not inputting your address and that goes and checks whether you're FiOS. Behind the scenes, a lot of operations happen, and that they go into different systems. Like whether your particular area, although it is FiOS qualified or not, is one thing, and then whether there is enough inventory and open bandwidth to support a service for you in that neighborhood or not, and so on and so forth. There are like 5 different operations that you need to do in order to determine whether we can accept your order or not. So for doing all that, you need to go through some parallel calls to collect all the data and so on, and you need to do some aggregation. And some of these functions at core system API level may have several other data that you may not need for your front-end experience. So in the past, we used to typically take all these services and implement them at the front-end level and gather all the data, and then it is up to the front end to kind of filter out all the unnecessary data or do multiple calls, and that as a result added a lot of overhead and the time it takes to get the responses back. So with this type of layered pattern, we could separate the aggregation part of it, filtering part of it into the process API space, and then have experience APIs deal with only the specific needs of the front-end application. That way, so now you could have multiple experience APIs for one process API if you have 2 different front ends that you need to cater to. And similarly, if you have multiple system APIs that you need to aggregate, you now have one place to do that part. That way, it intrinsically provides a good separation of capabilities and drives better coding practices. The next one, once the microservices are built that way, you now need to deploy them into a container, such as a platform as a service. So in this case, we used Pivotal Cloud Foundry, and our microservices, by the way, are built using Spring and Spring Boot that I covered in the first slide. So these, we are using Pivotal Cloud Foundry. Now, when you look at the different boxes here, these are all the out-of-the-box services that PCF offers that you can basically leverage and as part of your application deployment. Now, in the past, in a monolith custom code, several of these things we had to write custom code. Now, with a platform as a service, all these things are plug and play, and also they are based on open source industry standards solutions. As a result, it is not only the responsibility of implementing all these features is out of the hands of the developers, so they can only focus on the business logic, but also at the same time, the way they are implemented became very standard. Now, when we look at our application versus another application that's on PCF, all these are standardized. Now, from ops standpoint, that is a great benefit because the ops teams don't have to learn how to support different types of implementations and learn from it. Typically, when such discrepancies are there, the ops teams tend not to learn anything and then depend on the developers. So it becomes inherently a developer's headache to really manage and support the applications. with standardization of these features at platform level using PCF, it adds removes a lot of overhead on the development teams intrinsically. Initially, you don't realize it, but that is something that that is a great benefit you will realize. And in addition to that, in the past, for setting up a monolithic platform, if you even look at take out the initial parts of setting up the infrastructure and all those pains, once you reach the level where your servers are available, the core software is already installed, you still need to take care of implementing all these different things like load balancing and discovery of your services, all these things in addition to the security and other aspects of it by yourself. And that part of it became really plug and play, and scalability and other resiliency are the other features that also come out of the box, and that is something we have seen as a great benefit. One such example is this. Every year we go through this ritual of Apple launch, right? You guys all are excited about the new device that's coming, and on the day they are open to markets, you go to Verizon.com and try to pre-order. Now, a lot of people like you try to do that at the same time. Believe it or not, the moment the orders are open, we get about 30,000 orders per minute during the first few hours. So the systems need to kind of scale to that level to really handle that type of load. In the previous world, we had to kind of either take two paths. One, set up huge hardware that can handle this type of load anytime, any time of the day, and obviously that hardware will remain there unused, and it's a waste of resources. The other way to do is just, this time of the year the launch happens, you set up a temporary infrastructure and kind of set up the whole thing, do all your load testing, functionality testing and everything, and be ready for the launch. So Verizon tried all kinds of options. Over the past few years, the second option became more of an operational standard. But even within that, there is this 2-month, 3-month time period during which Verizon typically goes through this cycle of setting up the stuff and deploying your code, load test it, and functionality test it, make it ready. And every time the pre-order sale is open, everybody is like fingers crossed. Hope everything goes well. So obviously anything can go wrong, will go wrong. Several times you get the hiccups. But you get the idea. This is one example. There are several examples like that where even if you don't anticipate load, because it takes so long for you to go through the process of setting up your infrastructure and platform, you tend to overestimate your sizing, and then you always add a buffer of 40% extra space and capacity on your servers. As a result, and then still, you end up going through the refresh cycle again because some technology has changed, you need to do it. So like I mentioned, about 30-40% of our development capacity every year is typically allocated for just doing this stuff. So with cloud native platform as a service based architecture, these things became really plug and play, and the scaling became also automatic. We don't even have to really sit and do anything. You can just configure the system in PCF in a way that each and every service, you can go granular and expand them as you want, depending on the load they are taking. So that has reduced all our pain of going through these cycles of setup over the after we did this. Of course, we launched this platform for a limited functionality right now, but already we see great benefits in this area especially. Now, in addition to transforming the monolithic application platform, we had a lot of different technologies for the data store level as well. And it is not like intentional, we ended up that way. Over a period of time, these applications, these sections of the applications were built independently, and then they got merged, and we ended up in this situation that you see on the left, where you have we have Microsoft SQL Server for the shop-related data store, and Oracle for the learn part of it. So as you can see, the setup is not only complex, but since these are mission-critical applications, we had to deal with multi-data center setup, and transfer between the data between the data centers also is something that you have to account for in terms of your operational costs. Now, there are technologies like Golden Gate and all that, but they are not nearly enough in terms of ensuring the real-time availability of data across the data centers. So as a result, the side effect of this is that within our application, we had to implement things like session stickiness and all that to ensure we go in the right direction. Always that session goes into one side, and we don't end up with data integrity issues. So all that, now we migrated to a Cassandra-based cluster. Now, Cassandra intrinsically supports multi-data center data availability, so consistency. So that from that sense, all these operational headaches of data transfer, and also offline, we had to scoop this data out for our analytics and monitoring and everything as well, and also loading the catalogs and everything in the night is another big overhead we have. So that means we had to literally put our data into each one of these individual nodes to make sure all the servers have the catalog and everything. So all those overheads are gone now with Cassandra migration. Now, the other important thing we implemented is we used the data services available in the PCF platform to stream the data from all layers of our application, which means we went from the application level, microservices level, and every level. We write data into our Kafka queues, and then transform that into for various needs. It could be the real-time dashboard. It could be all the other offline analytics. We now have data in real time available. So that's another thing that's available. And one key thing we made sure it is done is the CICD process. So you could go to cloud, you could go to microservices, you can transform the whole stack. But if you don't implement CICD, you won't get the benefits. Primarily because now, if you leave this development, build, and deploy as individual cycles, and you do manual things like your unit testing and your code inspection and regression testing, you are still leaving out bottlenecks in the pipeline, and that results in manual work down the pipe. So CI/CD is something that is absolutely important, and going to cloud offers all these bunch of tools that you can quickly use to implement it. Now, I'll quickly go into the takeaways because this is the most fun part and kind of gives the insights into what are the things you need to care for. If you look at it, when you start on a digital transformation journey or any kind of major project, you need to make sure you have alignment, especially for a big, massive enterprise like Verizon. There are multiple organizations that are in the similar path. Now, it is important to get the organizational alignment before you go forward with your solution. Because down the line, when there is no alignment and the company is trying to consolidate the technologies, if you are the the odd man out, you are in trouble. So it's important to make sure you have the alignment, your architecture is aligning with the overall company goals and the strategy. Second thing is, there are generally as application teams, you tend to kind of wait. And by the way, I guess I'm out of time, but since there is nothing else afterwards, I'm just continuing. So hopefully you're all fine with that. Don't wait for the future and build it. So this is the Credo statement I covered in the beginning. But main thing is, what it means is, when the company is going towards an enterprise-wide transformation of technologies, as application teams, you can sit back and wait for somebody else to define what is the right stack and solutions that you need to implement, and then you can take that as a project and complete it. The other way to do it is basically we took that approach of being part of that process, where we participated in selecting the technologies and also kind of defined what we need. That way, all our needs are cared for upfront, and we get what is best for us in the process. Sure, there is a little bit of a challenge in terms of being the guinea pig, but sometimes it helps to be like that. That way, you get the cure, before anybody else. Now, I have seen application teams that also just take the half-measure approach, like change what is absolutely needed and leave the rest because they are working anyway. But as you saw in our technology stack, we changed everything, end to end. Whatever is needed to be changed, we changed it, primarily with the goal of achieving whatever objectives we set up front. So, several teams who did not do that, I have seen they are struggling now with bottlenecks and incompatibilities and situations where they still have overheads that they cannot overcome. So if you want to get the full benefits, go end to end and be bold about doing the whole thing across the board. And when you are selecting technologies, obviously you're dealing with a lot of vendors, and they have vested interest in maximizing the value from you. So they will suggest a lot of technologies that are specific to them, and you have to basically look at them with a grain of salt to make sure you're not boxing yourself into one area and or one vendor, and that might come back and bite us later. So just be aware of that and choose something that will still get you out of jail anytime if you want to change it. For example, there can be 3 different cloud caches available. There can be vendor-specific ones, there can be general ones. So if there is no reason for you to really be specific to the vendor-specific one, it is better to be generic like that. The next one, of course, if you ask the vendors, it's a controversial thing. They will not agree with you, but you have to be aware of that. Next thing is finalize your key design elements and your common components that you want to or the framework that you want to use upfront before you scale up to the entire development team. Because once developers come in and they want to implement your functionality, there is no going back. If it is not finalized, it will be chaotic. Within no time, you will lose control in terms of all the good stuff that you laid out as the best practices, and everything will go out of the window, and you will end up with all kinds of mishmash. So upfront, complete your research in terms of what framework you need, how exactly you want to implement, what design patterns you need, and and then you scale up. Do all the POCs until cows go home, but do all those things upfront. Now, other aspect is the training of the resources. So several people ask me, okay, how do you go about, you are moving from .NET all the way to Java-based technologies. So how do you get, train your team, and how do you basically make sure you have the capabilities to support the application? Yes, upfront, once you decide on the technologies, start training your people, because they are your assets. If the developers have the potential to learn one technology, they will learn other technologies, no big deal. But at the same time, if yours is a mission critical application, make sure you have some professional services lined up for the first 2 years. That way, you have a get out of jail card in case if there is a major crisis. And then I think we covered this already. Using platform as a service, infrastructure as a service, and all these things help you, create value by focusing on your core application, functionality, as opposed to doing busy work in terms of doing all the things that world has solved already before. Now, like I stressed before, invest on your documentation and CICD. It really pays, because if you have proper documentation, half of the handoffs and all the education is completely taken out. And then it also fosters a lot of innovation. Once people can self-learn, Uber has APIs. Are we calling Uber to find out how to use them? No, we are not, because they have great documentation. So same approach you follow, and make sure you have right documentation, insist on it, and if required, automate the process of generating documentation as opposed to taking a backseat. CICD, I already mentioned it. Now, let's talk about results. So in terms of results, when I compare what we were when we had the whole monolith and setup that is on physical infrastructure versus the infrastructure as a service, cloud native, and microservices based and on PaaS platforms, there is a huge lift in terms of the faster time to market and productivity improvements. You can see it's night and day. So several things my developers come back and say, okay, in the past we had to go through all these pains, now it's a click of a button. So it also is sometimes scary in terms of a click of a button, what things can happen. But if you have the right processes in place, this is something that will really set yourself in terms of the agility you want to achieve and the time to market you want to achieve. So if you look at it overall, to summarize, we set upfront a certain set of goals on how we want to improve the time to market, how we want to be agile, how we want to eliminate the overhead and costs. So as you can see, with our first MVP, we already saw enormous amount of benefits in terms of going towards this journey. So that's all I have. With that, we can, if you guys still have questions and patience for it, I'm open for questions. Go ahead.
The question is, have you selected some kind of products to go through this transformation, or that everything is now, do you have any legacy code left?
Yes, we have legacy code left, and we did not try to migrate the whole functionality in one shot into this. We are following the iterative process. So we first define a set of features that we want to implement in the MVP, and which are essential for making one customer-facing product end-to-end available. So we went ahead and did that. That's correct. That's correct. So we still have the BAU functionality on monolith that we will slowly transform into this.
How are you guys doing performance testing with device launch?
We use the standard tools like generation. We have scripts that we use to kind of simulates the end-to-end functionality. Using Windrunner, all kinds of Selenium scripts and all kinds of things to generate the load, and then we kind of throttle that to increase the load and test it out.
Good enough to mimic the customer experience?
Is it good for testing the customer experience?
It's good enough to evaluate the customer, mimic the customer experience.
Yes. Yeah. Yes.
How did you tackle the data migration? Because you're moving from one technology to another technology.
Yeah, fortunately, the area where we are working on, we don't have a lot of metadata that we needed to transfer. It's the Verizon.com sales and support applications. So those are the transactions customers are triggering. The only data we needed to load is the catalog data, which is something we do it anyway in the regular regular applications whenever we have changes. So that's the one-time load we had to do, and rest of it is customer-generated data.
So from a model, I'm sure you still have dependency on some of the data that master data comes from the monolithic application.
Right.
How do you handle the synchronization between now a cloud-based data store and the monolithic?
So those are the bottlenecks that still exist. Obviously, when Verizon moves all its applications and platforms to cloud, then the whole transformation will be complete. But what we made sure is that for the MVP, we picked whatever system APIs that are needed for supporting that functionality, we moved those into cloud. So whatever this MVP is operating on, from top to bottom, everything is in cloud. Right.
But you were running agile. So how was that?
So agile process is started when you started implementing the functionality. So what I meant to say there was to kind of finalize your design patterns and your framework that are common that people will use to implement the functionality. Things like how you do the logging, how you implement your security layer, and all those things. So those things, and for logging, and so all the common things that developers need to use while they're implementing the functionality is what we need to upfront design. And also the layered design pattern and other things that I talked about, an API first approach. So whatever is the methodology and process that you need to define on how people need to follow those guidelines are something you need to define upfront. If there is confusion a little bit, people tend to go tangential in that.
When you are designing, when you have multiple channels like a customer base and retail base, but has a similar functionality, then how you guys actually design? Is it specific to channel or common to channel?
Yeah, so we follow the product-based model, like I mentioned. So that product team is responsible for a certain functionality. So they literally treat that particular group as a product team. So they are responsible for defining all the requirements and needs for that specific product. So it could be.
Separate application for consumer, separate application for retail?
In the past, that's how we used to have. So, but with this architecture now, everything becomes microservices based. So the platform itself remains the same, but the specific services that you build on top of it will differ. And the individual product teams will be responsible for defining those.
But the UI side?
The UI side also will go with it. So the product team consists of 3 people at a high level. Your product owner, product team manager, and your product designer, and the engineer. So engineer is responsible for defining all your APIs and business logic and functionality and implementation. Designer is responsible for the UI and experience. And the product owner defines the viability of what is needed and prioritization of that. Anything else? Yeah.
So this relates to the previous
Exactly, that's the point. You need to upfront define the reference architecture. Probably go ahead and define a couple of example APIs as well. That way, people use that as a template to go forward with the implementation. All right, thank you very much. Appreciate your time.